Hi, let's do some computer stuff, yeah? Um, I am going to try and do some more floppy commands, I think. I'm actually slightly early as compared to what I'm trying to hit. Actually, it's 8:30 on the dot according to my clock, so nailed it. My on time is usually a couple minutes late, historically, with most things that I do in life, so I feel good about this. So we kind of have an open-ended mandate today. We can do a lot of things. I think there's really one thing we should do, but I've been skirting around it for episodes and episodes. Also because, the code hasn't been there to support it, and I've been trying to figure out how to make the floppy controller work, but maybe read write sectors, maybe? It seems like we're right there. So we managed to get the floppy, well, doing this much, I guess. Here, if you're tuning in for the first time, it now does this. Okay. That's the floppy by itself. That's not us. That's not us. Don't worry about it. But we have it like resetting itself and seeking to, I don't know, track 20 or some silly thing. And that seems to be working. So I guess the next thing to do is, like, we're at a sector. Is there anything we need to do in order to read a sector, write a sector? I'm spooked, but I think the answer is we got to do it. Let's review the ancient sacred documents, and of course, an evening to wear worm. First, let me crack open a seltzer water with which to gain my strength. So, yes, let's look at stuff and potentially steal other people's code. That's what we're gonna do. Sorry, just reading things. Oh, a common coding error example. Causes an infinite loop on most emulators. Well, I can ignore it. Anyway, let's see what we need to do. We seeked. We sooked. Yeah. So I think this is giving us like the main commands, and let's just scan through to see if any stand out besides reading and writing that I need to care about. So there's configure, which we did. There is version, which is the first thing we did. There's lock, which I don't think we really need to do, because basically I think that keeps you from having to send a new a new configuration command every time you reset the controller. Maybe something like that, but I don't care. Oh no, we did specify. I don't think we actually did configure, which is interesting. We could look at the code. That would tell us. So specify is for specifying things about, like, when you select another drive, it tells the controller what drive is selected, what kind of media is in that drive, all that kind of stuff. But I don't think we are actually sending a configure command, which is potentially, that could be causing some flakiness, but anyway. So we reset the floppy, just running through everything that we already did. We toggle the reset bit in there and wait for it to give us an interrupt, thereby saying, yo, your shit's reset. Which I also wonder if this might be what's going wrong, if you're just tuning in. Well, I'm going to show you again. So I did that whole reset thing, right? If I turn this off. Okay, so it's off. Turn it back on. See how it just seeked to 0 and then didn't do anything else? I'm wondering. Actually, that probably means it's getting as far as the recalibrate command, so I'm actually not sure. So I was gonna say maybe it's this wait for IRQ thing, and because the floppy controller is in a different state after power on than it is after reset, like this just hangs and you never get the IRQ raised, but that seems less likely to me. Anyway, then we send the sense interrupt commands, which are required for resetting everything. Set the data rate to 500K as per the documentation for a high density floppy, which we may have to knock down because this may be too fast for our sweet little Nintendo to read. Anyway, so yes, we're doing the specify command, like I said, which is not the configure command. Specify, like I said, tells it stuff about the drive. And then we send a version. For shits and giggles, do and seek. And so we turn on the drive motor. We do the recalibrate command, which is what pulls it all the way back to track 0. Oh, and then there's another wait FDC IRQ. So maybe it is the IRQ thing being weird and it hangs right here. Because it does the recalibrate and then not the next command when you turn the Nintendo off and back on without turning the drive power off and back on. So it's probably that. Anyway, I'm not worried about it. Because I'm just going to turn the whole thing off and back on again. For right now. So that's the seek command. We're seeking track 20. I guess the one thing that I probably should do is this configure command, because this seems important. Let's see. It initializes controller-specific values, the data buffer threshold value, so how much has to be in the FIFO before it tells you I need you to read something from the FIFO. Implied seek enable, which I think is with certain commands, like if you're going to read a sector on older controllers, or maybe it's even on different drives, but you would have to manually send a seek command and then a read or write command. I think implied seek allows you to just send a read or write command and it will do the seek part automatically. FIFO disable, polling enable, which we will need, so that's important. Good setting is implied seek on, FIFO on, drive polling mode off. FU, I'm turning drive polling mode on. Threshold 8, which I don't really know why, it's a 16-byte deep FIFO. Precompensation 0. If you enable implied seeks, then you don't have to send seek commands. Okay, so that's exactly what I was saying. If you leave the FIFO disabled, then it cannot buffer data. You will get a IRQ for every single byte. Nice. And it will overflow or underflow if you don't get to it quick enough. That's fun. Drive polling mode is just an annoyance that is there for backwards software compatibility. It makes you need sense interrupts after every reset. Always turn it off if you send a configure command. Okay, so maybe I do that because, I mean, I still just need to look for the IRQ, because right now I don't actually have interrupts hooked up. I just look for the IRQ flag in the requisite register. So maybe that's okay. Maybe polling mode is something I don't care about, and I can just look for IRQs. A big threshold such as 15 will wait 15 bytes between interrupts. So there won't be many interrupts, but you only have 1 byte left in the FIFO before it before it overflows. I get it now. Gotcha. That makes sense. So we want it right in the middle so that it still has a bit of buffer to jam stuff in while we're reading it out. Write precompensation is a technical thing having to do with drive head magnetics. A value of 0 tells the controller to use the manufacturer default value. So I guess we will set it to 0. So this is another one where I think we will do exactly what they tell us to do. So, like, configure seems like one of the first frickin' things we should do. So what I'm going to do is I am going to... Firstly, as Trade MC had said last time, really I should be taking each of these, like the recalibrate command and stuff, and moving them into their own subroutines too, so that I can, call these conveniently over and over again from different places. And at some point. Basically, I get things roughly working and then I will compartmentalize them. So anyway, let's do the sense interrupts. Actually, I believe they tell me in like the here's what you should probably do section on a reset. In what order I should do the resetting it, turn stuff on and off, and send the right commands, and at what point in there I should Send a configure command. Reinitialization. If you... Yeah, so get the version, whatever. I don't really care. I know what version my controller is, so I'm only using the version command just to make sure that it works. If you don't want to bother having to send another configure command after every reset procedure, I also do not care right now. So I think it is at this point that I send a configure command. So let's see. Oh, weird. It says to do a controller reset after doing configure and lock, I guess. So maybe the best place to do this... Well, under controller reset, it says do the reset if and only if drive polling mode is turned on, send 4 cents interrupt commands. It seems to be working. So I don't know if drive polling mode is on by default. No way to know, but I mean, unless I did something crazy, looked at the documentations. Send a new configure command. So I should do it right after the 4 cents interrupt commands. That sounds good to me. And so that should be as easy as, let's see. So here are my sense interrupt commands and the little loop to send for them. And I'll just do that controller configure right here. Configure the floppy controller. And that is pmuch load a literal hex 13 was the command. Yeah. Where are you? Yes, configure. Command was 13. First parameter byte is 0, so we will JSR send FDC command to send the command, then load a literal 0, and then do the same thing. JSR send FDC command. I never use assembler macros. This seems like one of those places where a macro would be ideal, so I could just have like send FDC command and then the command number. Not have to write 2 lines, but I'm not precious. That just seems like something that might be good. Okay, so now we have to construct this second parameter byte, which is threshold value equals threshold minus 1. Interesting. So if threshold value is 1, then the threshold is 0, I guess. So our threshold should be 7. And that's going to be the low nibble, so that will be easy. So it will end in 7. And then it's drive polling mode disable. And we do want that on, so that will be... So there's our hex 7, and then I'm just going to start assembling bits here. So that'll be in the bottom of the second nibble, and then FIFO disable, which should be 0, would be at the next one. And then implied seek enable, which we want on. And then I guess the top one is 0. Sure. And there you go. So that should be, let's see, that's a 5 right there, if I'm not much mistaken. All right, so load a literal 57 and JSR send FDC command. Then the precompensation value, which is just 0 again, according to what they have written. Plonk that right on over there. And just for fun, I'm going to start making notes on these. Param 1. Did it even say what it was? It just says it's 0. Okay. And 57 was param 2. And that is implied seek FIFO disable. Ooh, excuse me. Drive polling mode disable. Let's just drive poll and thresh, just so that I can look at this all later and be like, oh yeah, that's right. Param 3 pre-comp use default. Yay! And then there are no result bytes, and there is no interrupt. Ooh, that's interesting. I wonder if I should double check that. And I'm sure there is, you know, an error field somewhere in a status register that I should be checking. But whatever, we're just going to assume that it worked, because we're dumb. Right, but I wanted to see, so my thought was, I don't care about the version command, the recalibrate and seek commands. So recalibrate, do they send interrupts? Because that might be what my reset issue is related to, maybe? Is like unbalanced checking for interrupts. So since oh no, that's recalibrate does issue an IRQ, so that's fine. And then floppy seek does issue an interrupt. So I wonder if that's what's up. Is I clear the interrupt, but I still haven't cleared the interrupt. So let's put that here too. I don't hold out much hope, but it's a nice little thing. Like that's how it's supposed to be, and you know, maybe if we get lucky, that's like unbalanced waiting for IRQs is what's causing our reset to not work on anything but the first startup. So I think that's it. Is they pretty much, you just send the configuration command and then you just go, I don't care anymore, go off and do your thing. So I guess we build this, and ideally nothing should really change, but at least this is in a known state, which is good. And will you build? Will you build? Let's find out. Very good. Very, very good. Okay, as we do the usual pop it out, burn it cycle of things. What's going on in chat? I see a new face, Black Hatter, who says hello. Yeah, I was wondering when we would start the engineering process. Either it will, depending on your definition, it will either never start or it started at the very first video. And both are completely valid ways of looking at it. And Taco Man says, hey, hey, y'all. And good to see you, Taco Man. Always nice to have you in our midst. I realize I just loaded this, but I'm doing it again, damn it. That's all for chat. I would love to keep, you know, I'm trying to learn that skill of looking at chat while doing the programming thing, because we do the programming thing about 50 times an episode. I'm out of chats, so this is on you guys. All right, in you go. Power to the floppy. Okay. That was weird, but I'm going to ignore it. And power on. Cool. So it did it did the seek and everything. For sure it got to the seek. That's that extra little bump that it does before and after getting all the way to the end. For fun, let's see if that wait for IRQ thing made reset work better. Nope, didn't do shit. It still fails right after the recalibrate. Weird. Again, I'm not worrying about it too much right now. But if we kill power to the floppy, let it reset itself fully, then turn power on. Yep, there's the recalibrate, go to track 0, and then it bumps itself up to track 20. So at the very least, it hasn't broken anything sending that configure command, which is ideal to me. All right, so let's go on and try and do some more interesting things, like double checking in here what more I need to do a read, because I think we're there. I think we're there. And actually, I want to do a write. Cross my fingers that I can keep up with it, and ooh, I probably want to do a format, actually, because I don't know if this thing is formatted, so I might need to format a track. And I don't know that it says that here. let's look real quick at stuff. Read track, specify, sense drive status, write data, read data, recalibrate, sense interrupt, write deleted data, read ID, read deleted data. Format track is command 13. I don't think they have it documented in here. I might need to look it up. Format track. Yeah. Doesn't look like it's saying it. So, back to the data sheet we go. It's all the way down here. And we look at the commands. Here we go. This is getting real, y'all. So let us try. Okay, here's the table of commands. So that's read data and read deleted data. Write data. Write deleted data. Read track. Verify. That looks interesting. Format track. And they pretty much tell you, here's the input to this thing. Go hog wild. That's what you get. So I think this is saying... okay, so the command is 1101 and then MFM up here, I would have to assume, is setting whether it's FM or MFM encoding. Might be a density thing. Let's see if they give information down here. MFM. Oh, they have descriptions on all of them down here. Sick. Format track. The format command allows an entire track to be formatted. After a pulse from the index pin is detected, it starts writing data on the disk, including gaps, address marks, ID fields, and data fields per the IBM System 34 or 3740 format, MFM or FM respectively. And I am pretty sure we want to use MFM, so that should be 1. Okay. The particular values that will be written to the gap and data field are controlled by the values programmed into these values, which are specified by the host during the command phase, so we send those. And I'm going to need to look at what that is. I know there are descriptions of those in the system, but the ID field for each sector is supplied by the host. That is, 4 data bytes per sector are needed by the controller for cylinder head, sector number, which is R for some reason, and sector size, which is N for some reason. That's fine, that's fine. After formatting, the host must send... Wait, really? After formatting each sector, the host must send new values for those things for the next sector on the track. The R value, which is the sector number, is the only value that must be changed by the host after each sector is formatted. I guess that makes sense, because it needs to write the sector number. And apparently the controller just doesn't do that automatically. Oh, this allows the disk to be formatted with non-sequential sector addresses. Interesting. So it puts the power in your hands. The incrementing and formatting continues for the whole track until it encounters the index pulse again. Table 6.8 contains typical values for gap fields, which are dependent on the size of the sector and the numbers of sectors on each track. That looks tasty to me. Table 6.8. Is that this one? No. That is this one. 3.5 inch drive. So we're gonna go whole hog, and we're gonna try to treat this disk as a 1.44 megabyte high density floppy. We might have to just knock it down and make it a double density or something, which is still fine. We will see. We will see how fast we can keep up with this thing. But let's see. So sector size, of course, is going to be 512. That's universal. N, which is... Oh, these are like the gap things. NSC GPL1 and GPL2. NSC GPL. I don't know what's up with the data field. Let's see. Let me actually look at the command again, because do they literally mean like the data that goes into the sector? I don't think they do. But that would be good to know. Oh, so filler byte. So I guess that can be whatever we want. I'm going to assume. That's probably useful for some things, but it looks like it's maybe a user controllable thing. So we set the bytes per sector, the sectors per cylinder, and the gap number. The first thing. Let me just start writing notes in my code, because at this point there's a few things to keep track of, and I'm gonna need to keep track of them. And for fun, I'm just gonna, well, because for sector number, this is getting so low level, and I need to be careful. Well, it's not like I'm gonna screw anything up, but as far as the sector number, surely it's the sector number for that track, right? Not for, like, not that LVA sector address. It's got to be for that track. It's got to be, because I was, yeah, let's not worry about that. We'll just assume it's for the track. Because I was going to say, does it matter what track we're on? Because we're on track 20, and that's where I'm going to play around right now, but I think that's okay. Okay, so we send. Let's just do it. We recalibrate, we seek. Finally, let us try to format the track. So the first thing we need to do, let's just write out some pseudocode here. Send command with mfm bit on, then send bytes per sector number, then send sectors per cylinder number, then send gap 3, then send filler byte, then and the fun thing is, we also want to not overflow the FIFO. So we're probably going to have to check some status crap. Actually, I guess if we're using send commands, the floppy controller is already going to be telling us whether it's ready for more data. So that actually should be fine. And then, for each sector on the track, we need to send the, okay, so it was cylinder, sorry, scanning, reading, scanning, format track, it was cylinder head sector number and sector size. Send cylinder, yeah. Okay, yeah, so my talking about the sector number is of course silly, because we're encoding the cylinder, or for the sector number, because we're encoding the cylinder and the head number and everything anyway, so. Send head number. Oh, I should probably select a head, huh? That's probably a thing that is supposed to happen. Send update, or maybe rather increment sector number, send sector number, and perhaps, Actually, let's do the increment at the top because it's waiting to get to the next sector before it's ready for this information to be written. So this will probably be in dead time, and then we'll get here, and it will be ready for us, hopefully. It won't really make a huge difference, I don't think, but it makes sense to me. Okay, so send sector number and sector size. Send sector size. Lovely. And then we do that for each sector as listed, which should be 18, I think. And we will fill those out once I actually start turning this into code. Format track. So we do that, blah blah blah. Then we read 1, 2, 3, 4, 5, 6, 7 bytes is what we do. So what I'm going to do is I'm going to write this and you know what I'll do is I will stash. I was trying to figure out what the easiest way to just run this and then make sure it did something or check the results would be. And I guess what I'll do is I will just stash these ST0, ST1, and ST2 values into the 0 page like I did with the version number, so that we can just check them and see if it worked out. And yeah. So I think that's like the whole thing. I guess the last thing is read STO, read. Let's do read STO, store STO, read ST1, store ST1, read ST2, store ST2, and then how many? 4 undefined bytes. So read 4 more undefined result bytes. And then the last thing I want to know is it gonna, does it send us an interrupt every time it's ready for a sector? Or how many interrupts does it send us? And do I need to be waiting for interrupts? Whatever, man. I'm just gonna go for it. I'm just gonna go for it. And then when it doesn't work, we will figure out what things we didn't pay attention to that might be important. So I like how so they have GPL1 and GPL2, but how do those correspond to the gap3 number? I'll check that out in a second. But right, I need that command number. That command number is format 1101, which is 2 less than F, which is ED. That's a D? Yes, because 1100 is a C. That is D. So it's going to be, with the MFM bit high, it's going to be 0100, which is 4, so that's going to be 4D. Brought to you in 4D Floppovision. Yeah. So that's just going to be LDA. What did I just say? 4D? 4D. And JSR. And FTC command. I saw that it cut out, and I just kept typing because translating this is now going to be quite boring for you. But let us... Okay, so I was looking up N. So there's a sector size code. And we want... apparently 02 is the one for 512 bytes. Cool by me. We'll make a note. 512. And then the next thing is my values that they just tell me, my magic values that they say don't worry about them, just use these, everything's gonna be cool. So my N was 2. Oh, right. N is 512. Okay. My sectors per cylinder is 09. Interesting. I would have thought that was 18. Fascinating, because this is for single density? Does it not have the info on, or does it not support double density floppies? Oh, wait. Oh, no. So, I mean, support high density. But it has the perpendicular format 2.88 meg. Oh, because two heads. Two heads, right? That's probably what it is. Oh, and that just goes back to the whole thing of I probably need to select a head. I probably need to select a head. That is probably important. Because right now I'm not sure what head on the drive is selected. And that's important. I mean, it's not like it's going to super screw me up, but when I get to actually like trying to do structured data on this floppy, I'm going to want to know what head is selected. I think I'm okay to ignore it for now. It's going to be one or the other. And if I write the wrong value, I write the wrong value. I'm not sticking this in another computer right now, so it's not going to screw me up too bad. Okay. So, I guess we write 9. Which now we're going to have to go back and double check, because if this gets funky, I had set the data rate to the one suggested for a 1.44 megabyte floppy. Anyway, let's just move on. So if those don't line up, they don't line up. We'll figure it out eventually. For right now, the fun thing is I can probably write all kinds of wrong stuff to this floppy with like the sectors set up in the wrong way and my, data rate and stuff all screwy, and it will be fine when I read and write my own thing. It's the interop with other machines. When I stick it in, it goes, whoa, 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 this does not look like a correctly laid out floppy, that we will run into trouble. So right now, we don't have too much to worry about. When we start getting more structured, it's probably gonna come back and bite me in the ass, because I feel like this should be 18. Anyway, so did I put that in there? No. I'm gonna do what they say. Oh, and I should probably send these, right? JSR, send FDC command. JSR, send FDC command. And then we do the gap 3. So the gap 3 is the other part that I don't quite get, because I'm sure it has something to do with these GPL1 and GPL2 numbers, but they just say send the gap 3. So now I'm going to need to look at what that is. For gap fields, yeah, sure. Let's see if up in the definitions of things they say what gap 3 is. Gap 3, gap 3, gap 3. Tell me about gap 3. Gap 3, gap 3, tell me. See, that's interesting. A 1 selects the double density mode. But double density is not. Anyway. Alters gap 2 length when using perpendicular mode, whatever. Oh, GPL3, the gap 3 size. Gap 3 is the space between sectors, excluding the VCO synchronization field. Sweet, so what's that supposed to be? Because it just says GPL, gap 3, that's fine. But what are some good known values for it? And then it gives me GPL1 and GPL2. Oh, wait. Okay. I should read the notes. So GPL1 is the suggested GPL values in read and write commands, basically to avoid shit running into each other. GPL2 is the suggested GPL value in the format track command. Ah, interesting. So I want to use 54. And I'm just going to do what they tell me. Load A, 54. Send gap 3. And then I'm just going to send, I don't know, send the actual command. That's a good idea, firstly. And nope. Nope, that is not the right thing. Don't trust your editor. Read what you are doing. So, yeah. I guess I'm just going to do 0 because I don't know that that matters. JSR. You know what? Let's check the definitions on that one as well really quick. Because they're up there. And they say things. Oh, too far. Too far. Looking for symbol D, data pattern. The pattern to be written... the pattern to be written in each sector data field during formatting. So I guess it just repeats that byte. Oh, okay, that's what they mean by fill byte. It's not that it's like just a filler byte means it's the byte that it's going to repeatedly write into the sector when you clear it out. So that should be useful actually. If I if we do something distinctive like 5A, then if I format this thing and then try reading a sector, it should return me a big pile of 5As. So that's another way we can check. Okay, so that's the initial setup. And I close the file again. And because that was a bit of a mouthful, let me look at chat because I think it's been flowing in. So, Eric Stern says, lurking as per my usual, nothing to see here. That's totally fine, Eric. I know there's a lot of people who, well, a lot. There's a decent proportion of people who just watch and never chat. So that's totally fine. I am here to be for people to be voyeurs. That's the whole point. Where we said, don't start with format, start with read sector. Try and read the boot sector, for instance. You know, you're probably right, actually. Let me do this format thing and fail at it, and then we'll comment it out and... Right, sorry. As I was saying that, it was occurring to me that surely there's a reason I'm not doing that. And what it is, at the moment, I don't have a convenient machine to write a floppy on, as bizarre as that may sound. This is ripped out of my Pentium machine, which is all taken apart. My IBM machine, my Pentium 4 box, is the box that I took this floppy ribbon cable out of because I couldn't find another floppy ribbon cable, insanely enough. And then I have... actually, you know what? This makes way too much sense, because what I was about to say is I have a Dell Pentium 3 box that is having trouble booting right now. Like the memory is just flaky on it. It's really annoying. I was going to use that one to write my floppy, but what if I just go steal the floppy ribbon out of that machine, move it over to the IBM machine, write my floppies on the IBM machine? Okay, that's what we'll do after this doesn't work right. Okay? I mean, I'm sure it'll do nothing, but yeah. We'll stick that floppy in, and we can write known data, because that is the thing, is really we should... The whole thing that I was saying about I'm causing myself a bunch of potential headache by potentially writing data on here that I can read and write just fine because I'm using my parameters, but they're not parameters that any other machine uses for a standard floppy disk, and it will confuse it, and I want to be able to slap files on here from another computer, is the idea. Is that I probably want to start with known data and attempt reading it to make sure those parameters are correct before I do other stuff. But anyway, let's just try and run a command. All right. Blackadder said, yeah, my definition of engineering isn't very specific. Good. Then we've been doing it the whole time. Eric Stern says, what about checking write protect? I'm not sure we can actually directly check that. We mentioned this at some time in the past, but I'm pretty sure write protect is like invisible to us. I think that the controller just doesn't send data to the head when you do commands when you have write protect on, but I could be wrong about that. There's got to be a way to detect it. I don't know. But anyway, we've already run other commands, so that one, doing that wouldn't be particularly interesting to me. Megaton says, yo. Daniel Rodriguez says, hello everyone from Chile. Hello, Chile. Man, all the way down in Chile, huh? That's wild. I don't know where you stand on the recent referendum there. And it's not my job to get into your politics, but that sounds like it must have been fun, is all I will say. And I hope that things are going good. I mean, it seems like things are relatively stable. That was an interesting vote. Worm says you can't even verify the format unless you have a read function. That is true. Blackheader says, yep, to something. Lil Rib 9012 says hi. What's up, Lil Rib? Francois Reval says H, which I assume stands for hate you and everything you stand for. And that's pretty rude, Francois. I'm not going to lie. Worm said, yeah, if only we had a GoTech. You know that defeats the whole thing here. You know it. Francois said, hi, so does it work? Yeah, totally. Gerald said, hello, I saw selected head 0 or 1 through scrolling the dock FY. Yeah, I thought one of the things that I did selected the head. I'm not paying attention to which one it was. So thanks for verifying that for me. Wereworm says, write protect should be detectable as we are no longer in AT mode. Right, that was the thing. Is we had the floppy hooked up in non-PS2 mode before. And Wereworm says it was a bit in one of the status registers. Yes, that seems right to me now. But I don't care. I'm fine with destroying all the data on here. Oh my god, Francois says 3 a.m. already? Dang, man. I'm pooped and it's only 9:16 over here. Gerald says, yeah, GoTech would be better for testing, examining disk images and so forth via USB and not break the disk. I am fine with breaking the disk. I mean, you can't break the disk too bad. You're just gonna need to reformat it when you do it wrong. Francois says, great, so if it works, I can go to bed. I'll finish the SIGROC driver another day. Sounds good, Francois. You can always try your best to catch up tomorrow. Hopefully this one won't go too long. We're already 47 minutes in, and I'm talking about swapping cables around in the machine. Yeah, screw it. Here's what I'm going to do. I'm going to save off this code. Going to save off what I had started writing for format track. Because I'm going to listen to my Better Angels right now. I'm going to stash it over here, and I'm going to actually save this file as format temp.asm. Cool. And now, yes, you're right. I guess because you have been staring at my screen for a while. Oh, sorry, did it again. Gerald clarified, not breaking the disk, breaking the drive. And he says, though they are pretty robust. Again, I don't think I can break the drive through software. I really, really don't think that's possible. We'll find out. Right, anyway, what I was saying is you've been staring at this screen for a long time, so why not? I was trying to decide, should I proceed to write the read sector code first or write the floppy first? And I'm going to go get this set up working first because you could probably stand to have something different to look at, I feel like. So, yeah. This might require a little bit of scooching because I got to move this camera around, and I should probably move my mic because it's not going to pick me up at all. But that's going to screw up some things. Anyway, bear with, is all I'm saying. I'm over here. I'm here. I'm getting over there. Okay, and now my mic stand is falling over. That's totally fine. I hope that is not hurting your eardrums too much with all the banging. Okay. We have a microphone. Hi. Now I just need to reset this camera and make it look somewhere reasonable. Okay, there we go. That's not half bad. And you can just take a skiz as I open up a computer and steal a floppy cable and put it back into another computer, and that's it. Oh, thankfully I already have peripherals and stuff plugged in here, because after I moved these desks around a while back, particularly for streaming, and nothing is plugged in, and no power is run over here or anything. I do have the peripherals and whatnot plugged in because I was trying to use the Dell machine. Yep. Werewolf said, read Sector 0 and check the magic number at the end of it. On a bootable disk, it is 55AA. That is true. That is the magic number, and that is a... I mean, it doesn't really matter what I put on there. I'm gonna make my own floppy image so I know exactly what's going on there. But reading the last byte is probably the smartest idea, because that will tell me if I had an underrun without me having to check any status bytes and stuff. So it should be as easy as actually executing the command, reading the data, and if it finishes, reading the last byte in the buffer, last 2 bytes in the buffer, to confirm it got over there properly. Hello, floppy cable, where are you? You are there. Ooh, there's another thing, is... Oop, sorry. I have to hope this little dinky short cable from the one machine makes the run in the other machine. I mean, if not, I just have to pop out the floppy drive, whatever. I hate this side panel. Hate. I don't hate many things. This side panel is one of the few. Okay, so where's your plug, bud? Where's your plug? Where's it hiding on me? Those are IDE. Is it hiding behind them? No. I mean, you know, I just unplugged this thing a couple days back. You'd think I'd remember. Oh my goodness, this is all the way at the bottom? That's not going to stretch. That is not going to stretch at all. No, sir. I am going to have to take this floppy out. Hopefully it's not too painful. No way that's the... No, that's a high-pitched connector for something. Oh my lord. Dusty old cases that I should have cleaned out ages ago. Can't see anything. IDE, IDE. Was that it? Sorry, bear with, sorry. Like, I don't feel right. I don't think that's it. I don't think that's it. But where is it? This thing has a floppy drive. Oh, here. Oh, wow, that's nasty. It's under the power connector. Buried as hell. What the? How did I get this out of here? Who did this? Who designed this? I hope chat's having fun, because I am not looking at it. Yes. Yes, this is it. If it works, that's all I care about. Okay, that might actually just barely make it. And come on. Come on. There we go. Thank you. Thank you very much. That not so bad. Give myself some peripherals. Get this thing booted up and try and think of a good way of getting you close to the monitor so that you're not watching me from across the room. And I had a power cable and it is gone. Please work. I haven't fired this computer up in a while. Oh, the monitor's totally not plugged in. That would be an issue. There we go. That's good. Okay, I'm going to look at chat and I'm going to think about moving this camera. What do you say? Wareworm says, implementing the FAT will be a funny ride. Wareworm said, is the computer on the right your score from VCF? Yes. This one. In one of my videos, it was actually the one right after VCF. I did a little show of this. I was going to say maybe it's plugged in, but no, it's not. I might be able to plug it in if you want to see it in the background. I'm not sure I have enough cables. I'm not going to worry with it right now. We're doing enough silly things. Let's see if I can remember my own password. No, I can't. No, I can't. No, I can't. There we go. Eventually. Okay, find a thing to put you on, everyone. Prepare yourself for vomitousness. Sorry. It's gonna happen. It's just gonna happen. Yeah. How's that? Is that any good? Is that perfect? I don't know that I have anything taller. Wait, one second. There. That's a thing. We're on a side table on a suitcase on a side table. That's how we're doing this right now. Is this a waste of time? Probably. Does that make it worth doing? Absolutely. Okay, whatever. Good enough. It's always going to be shit anyway. Oh, more chat. Sorry, I'm getting my floppy. Okay, yes. So, reading some chat. Francois Raval says, no, it's different on Atari DOS floppies. Oh, I'm sure it is. I am sure everything is different. Hi. Hello. Hi. Gerald says, what size? Fat 8, 16, or 32? Or some non-specific fat in between because funny. It's 12, 16, and 32, FYI. I only know this again because of too much messing around with stupid operating system hobbyist crap. It's one of the few things that I do remember. And it is, interestingly, not determined by... what determines your fat version is literally the number of sectors on your disk. If they are above a certain value, it is that next version of fat, and that's it. So you can't, like, say what version, and they are all kind of interoperable-ish, as long as your software is written to understand them. But anyway, the extra point there being that fat 12 is the fat for floppies because that's just what it ends up being. It's not that you have to specify it's fat 12, it's that it ends up being fat 12. Because that's how big it is. Santiago says, do you run a Windows domain on your vintage network? I do not. Well, yeah, no, not currently. I totally should. Because, I mean, you can probably set up this Windows 2000 Professional as a... Can you set up Windows 2000 Professional as a domain controller? Because I'm not sure. I would imagine that would have to be Windows 2000 Server. But, I mean, it's not like I can't find a copy of Windows 2000 Server. That's completely legit. But no, I don't currently, but that's a good idea. Santiago says, also hi. Santiago says, I'd like to have a domain on my network, but virtualized on a Raspberry Pi or Odroid. Not sure if I can go with vanilla Samba stuff. Haven't really checked. More power to you. Older school Windows domain networking is an interesting thing. Worm said toddler view. Gerald says, nice brings back memories, shoulder serving dad. Santiago says, I've used FAT12 on the file system used on old Sony Ericsson phones while hacking them. Dope. And Gerald says, Anyway, let's do this thing. So let me see. Let's cross our fingers that I have a hex editor of some sort on here. Or something I can use. Because let me see. I should have floppy images in here. Yeah, I know. God, that's so bad, the flickering. Look, it is what it is. Look away seriously, please, if you have, the thing where your eyeballs make you die. I'm not that stupid. I know what it's called, and it's just escaping me right now. Eurythmics. That's what it's called. Anyway, I definitely have floppy images on here. I just can't verify their content. Let me see. Let's do this. Let's rename this to win98 boot.img for writability. I have no idea where this is in the file system. CD, SIG, drive, C. God, what even is it on Windows 2000? It's been so long since I've been around here. C. What is the users folder? Where is it? Oh, documents and settings. That's right. Admin. And my documents. Yes, my documents. And then I guess, do we have hex dump? No, we don't. Awesome. There is a way to do this, right? Without hex dump? Maybe. This machine isn't on the internet. Epilepsy, that's what it's called. Thank you very much for making my dumb brain less dumb. Tacoman said, wait, I had to step out. Why are we on Windows 98? A, it's Windows 2000 Professional. B, because we're making a floppy disk image. You know what? Let's just... The whole idea is plow ahead. Is plow ahead. So how's about we just write this disk, and I mean, it's a bootable Windows 98 boot disk. So that 55AA should damn well better be at the end. And if we get something weird, then, which is more than likely the case, then we'll just deal with it at that time. And hopefully, this is actually a good image. .40 megabytes. That seems reasonable. Like, I could have used any of these. I have a bunch of different disk images. Like MS-DOS 5, for example. Oh, wait. That was 3.5 720K disks. So that actually might be useful if we decide to go double density. This is, okay, that's full fat. 1.44. Drive cannot find the sector requested. Neat. Let me actually make sure I format this first. Probably a good call. And actually, I am going to write one of these DOS images, because I know the DOS images are good. I feel like this Windows 98 image, there was something wrong with it. One moment. Santiago, yes, we're just cloning a disk image. And I'm not using DD because I'm pretty sure it does funky shit with floppies on Sigwin. I think it is not ideal. But I have raw rate, so I'm going to use raw rate. And this is having trouble. Maybe I shouldn't use this floppy. Maybe this floppy is bad. Because it sure seems to be slowing the shit out of my computer. Which doesn't need any help in that department. Oh, come on, brother. Okay, so either I did something wrong with my floppy. No, it seems to be making the right... having the right lights on the drive and stuff, so it's not like I have the cable run backwards. Okay, I have used this floppy for Windows for Workgroups, so that better be good. I'm getting a lot of recommendations here. WinImage, Win32 Disk Imager. Here's the thing. Here's the thing I'm going to let you in on. This thing's not connected to the internet, and I don't feel like transferring files over right now. It's not that bad. This thing has USB. It's Windows 2000. I could get files over here if I had to, but I prefer not to. Yes, yes, yes. Quick format, go. Taco Man says, I see Deus Ex. Yeah. So I never played Deus Ex back in the day. I had an uncle, family, friend type person who played it and told me how great it was when I was a young lad. So it's on my list of games to play that I have not played. And I still have never gotten... I don't think I've ever made it past the tutorial. Oh, no, I have. No, of course I have. I've made it to... made it to, he says, when the next thing that's going to come out of his mouth is the Statue of Liberty, which is the first thing in the game. I don't know. I was really hoping it would be my type of thing. But maybe, you know, maybe I'm spoiled by all of the developments in the stealth genre that came out after it. Not that's a stealth game. I know it's not. But trying to stealth around the initial area sucked. I'm just going to say it. Made me sad. But I need to try it again. That and, because it's kind of in the same vein, the original System Shock, I would really like to... It's, again, one of those ones that I've picked up and played, you know, like 10 minutes of a bajillion times. And I should really give it a longer chance. But I haven't had time for video games lately, which is a shame. Yay, image successfully written. I will take it. I would love to have a way to look at the content of this image or this floppy. And I don't think I really have anything convenient. I would have thought I would have put XVI32 on here. There might be some stuff in DJGPP. Maybe. And I'm sure there's command line tools I can use in Sigwin. Probs. Tarring stuff. UCC, of course. Object copy, object dump. No, not really. Let me look directly in Sigwin's bin folder and see. Do we have like OD? Do I have that installed? or whatever. It starts with an O. LMNOP, that's how it goes. I'm sure you can't see anything on the screen. OD, that's my one, right? Yeah. Hello? Yes. Okay, cool. Man, OD. Tell me you have documentation, because I can never remember how to use OD. OD, because it does like octal by default, because it's octal dump. Dash T. Anybody want to tell me the OD command for dumping hex bytes? Santiago says, I have never played it. I saw a review from Ross of Accursed Farms, and seems like it's not my PL type. I was about to say, I don't know what PL stands for. I must be out of the loop. Yeah, I don't know, but it seems real cool. Taco Man says, I played the online multiplayer a lot back in the day, mostly because that's all I had. That's fair. I didn't know it had multiplayer online. That's neat. Wareham said, I think Norton Commander had some disk editing thingy, if I remember. You think I have Norton Commander on here? I might. I don't know. Anyway, format. How do I specify it? Format. Tell me. Select on-site decimal 2-byte units? No. Select octal 2-byte units, decimal 2. No, I want single byte units. Okay. Type is made up of some shit. So I think it's just X1, hopefully. Let's see. Echo, hello. Now I'm going to pipe that into OD-T. What did I say? Is it just going to be TX1? Yeah, awesome. So let's do cat. Let's actually go to the MS-DOS floppy. Again, you probably can't see shit. Here, let me move this window over here. That might make it slightly better. You might be able to see what's going on. Oh, right, and I have to go back to sig drive, see documents and settings, admin, documents. No. My documents? Weird. And then to MS-DOS, Microsoft DOS. And I used a 3.31 image, right? So cat disk1.img. Oh, damn it. How do I limit the output? Like, I just want to take the first 512 bytes. Okay, let's do it hardcore way. Cat disk1.img, pipe that into OD-TX1, and then pipe that into disk1.hex. Vim disk1.hex. Damn it. Vi disk1.hex. And go to, shoot, what is the, is that 200? No, surely not. What is 512 bytes in hex? 100 is something nice and round. I mean, that's, every one of these is going to be 16. So that's 16 times 16, which is something nice. Let's just do the calculator. Run. Right. Old Windows. Programmer. Wow. No, there is no programmer. It's just... Okay. Decimal. 512. Hex. 200. Okay, so I'm not crazy. That just seems like a very small amount of data. A whole sector is just this. It's just that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14, 15, 16. Yes, so this is correct. Wait, no. That's not correct, is it? Why would it be? This is 32. So that's why my addresses are doubled, which is weird. So it would be 400. Oh, because these addresses are in octal. God damn it, OD. God damn it. That's why. So it would be 400. Right? Yes? Let's see what it is in octal. No, it's going to be a bunch bigger. We have orders of magnitude here. Decimal 512 is octal 1000. I'm not crazy. That did seem very small. 1000. Here we go. And there you go. That's all I was looking for is that good old 55AA. But the nice thing is I can come... Sorry. I know you can't see that, but this is the last 2 bytes right here. Here. Right there. You still can't see them. Those are 55AA. Which we could have assumed, but they're there. So we know they are there. And now also I can look back at this if we only read some partial data and it goes wrong to see if at least we started reading the right shit. And now, let's write some code and then not actually execute it. Does that sound fun to you? That sounds fun to me. Because we're running real low on time. I'm probably already over where I want to be. But let's scoot everything on back over and I will let you chat and we will maybe give it a shot. I have other work to do, but I also demand results from this show. I really do. And sometimes we just have some long periods of, like, making this episode, I wrote the DOS 3 boot image to a floppy. Not very satisfying. You know what I mean? Okay, we gotta fix this shit up. Come on. Okay, we're at an hour 17. There is hope here. If I just try and bust out this code for reading. All right. Let's read some shit. Francois says section examples, which I miss what that is referring to. However, he subsequently says, c'est tout en bas de la page de mon bien sûr. I studied French for a minute, and then I went to France, and I tried to ask a man, does this bus go to Notre Dame? And he looked at me with such concern as I tried to do it. And that is the peak of my French. Yep, Worm told me ODTX1. There we go. And that 256, yep, and yeah, and then it was octal, so yeah. Santiago says, it's part of progress, so, you know, I like this whole scene that we've got here. I really appreciate, you guys really seem to be there. You're like, don't get down on yourself for not providing the people the results. Just keep grinding, man. That's what we're here for. And you know what? I really appreciate that. Just for no other reason than that's the kind of attitude I would like to cultivate. Anyway, I'm turning this on, and I don't really know why. Because I wanted to. Really, we should just be writing code. But I just want to see it do its thing again. I mean, come on. There we go. Nice seeking, bro. Taco Man says, I'm here for moral support because I'm lost on some parts. That is totally fine. We just wrote some shit to a floppy. We're now going to try and read that shit off of the floppy. So, to the code window we go. We need to go to the place where, firstly, I'm going to need to update this seek command because we want track 0. Track 0, my boy. That's what I'm saying. That's what we're here for. And now, do a Read a sector, maybe? All right, let's look at the read sector command. Let's look at it. Let's just do it. Okay. All right. Read write. Remember, this is in CHS, which shouldn't be hard because it's going to be cylinder 0, head 0, sector 1. That's it. Oh, right. Let's go back. And I was told that there is something that in here says something about setting the head number, which is important. Let's see. So this was setting drive 0. That doesn't select the head as far. Sorry about that. That's the most reconnections we've had in a while. The read command itself actually might just specify the head to use. I think that part is fine. Hopefully. Anyway, let's do the part where we just do what they tell us to do. So, read command empty bit, MFM bit, and 06. So, MT and MFM. Let's leave this guy open really quick so I can refer to the definitions. MT multitrack. When set, this flag selects the multitrack operating mode. Treats a complete sector under head 0 and 1 as a single track. Interesting. I don't think I want to do that. So we will set MFM to true. See, again, here's that thing. If I want to read... Well, actually, that's just... So MFM and FM are the magnetic encoding format, right? Like, FM is literally... I think it's literally frequency modulation, isn't it? I'm probably wrong about that. But anyway, it's how the magnetic flux is put on the drive to represent the data. So I think a high density still uses MFM. It just has a higher data rate. So I was freaking myself out about that before, but that's probably fine. I just need to make sure MFM is turned on because high density also uses MFM. Anyway, yeah, I might just have to use the document because I don't know where the MT bit and the MFM bit are supposed to be. It doesn't tell me here, so I'm just going to read from here. Okay, here we go. Read data. All right. Same thing as before. So it was 6, and then MT is the topmost. Don't care. MFM needs to be 1, so this will still be 4. What the hell is SK? See, they don't even tell you what SK is in the wiki. SK, what are you? SK, skip. Sectors containing deleted data address mark will automatically be skipped. That is useful. Interesting. So I'm assuming we want that to be 0. So this is going to be 46 is the plan. So that's the first thing. Read data. 46. Let's kick it off. Load A. 46. Read sector command MFM mode. Send FDC command. Next is, yep, head and drive select. So it's drive 0, that's fine. And head is, I assume HDS is heads, and that is going to be head 0, I assume. H head address selected 0 or 1 is encoded in the sector ID field. Well, let's hope it's 0. Come on, brother. Come on. Read data. So that's going to be 400. So 04. Heads and drive. Or no. Head 0. So it's just going to be all zeros. Load A 00. kid 0, drive 0. Send it. Next is cylinder. Cylinder 0. Boy, this is really easy when it's the first thing on the disk. Cylinder 0. Send it. Why does it keep trying to go back there? Head. Head? Really? Did I just set head there? Whatever. I'm sure that's there to match the encoded sector information that's actually on the disk. Yeah, H or HDS. Whatever. Don't worry about it. It's 0. It is also 0. Load A 0 0 head 0. Send it. Now R, which was the sectors per cylinder number, right? Which actually, that's the part where we're going to have to be clever. I mean, maybe clever is the wrong word, but... Oh no, that's no. N is the bytes per sector. R is the sector address. That's right. So that's going to be 1 because sectors start at 1, and then N, which is going to be O2. So load A, sector 1. Whoops, almost screwed that up. JSR. Send FDC command N, which is the thing we just looked at. That is the sector size code, which is O2 for 512. Load A, O2, 512 bytes per sector. Send it. All right, and then we do what? EOT. All right, here's where we're starting to get interesting. What the hell is EOT? EOT, GPL, and DTL. I'm going to write those down so I don't have to keep scrolling back and forth. EOT. Thank you for being helpful. EOT. GPL and DTL. Let's go look up what those is. EOT, EOT, EOT is something. It is something. Tell me what it is. EOT is something. End of track, the final sector number of the current track. Which would be, we're going by sector numbers, so that should be sector 18. Should be. Should be. Should be. I'm just going to write it in decimal because I'm lazy. Final sector of track. Send it. Then GPL is that's the gap, right? Gap, which they gave us a number for. So for 512 MFM, the gap number is, read and write commands is GPL1, and they are saying that is 1B. They say, use 1B, please. So I will. What do I call that? Gap 3 number from the manual. Send it. And DTL, last one that we have to send before we start reading sector data, hopefully. DTL. DTL, what is your secret? Tell me your secrets, DTL. Special sector size. By setting n to 0, DTL may be used to control the number of bytes transferred. Interesting. So, like, you can read partial sectors? Or weird length sectors? Funky. So, I want to not use this. I guess by default, because we're not setting n to 0. So I'll just use 0 for DTL. Load a 0, 0. DTL. Not used. Or maybe note self only used if sector address is 0. Okay, that's all of the basic setup, theoretically. So what has to happen next is the part where we actually have to keep up with the frickin' drive. Execution. Data transfer between the FDD and the system. So we just read until we can't read no more. And by can't read no more, I mean until we have transferred 512 bytes out of the FIFO. I think. That's just what I'm going to do. I'm just going to go ahead and do it. I guess this is one place where checking the wiki might be useful. Okay, they don't tell you what the read phase is, so must just be that. If you try and read the result bytes without waiting for RQM to be set, then you're going to get shit values. No duh. If you see there's no sector count parameter. Oh, you'll see there's no sector count parameter. Well, no shit. I'm only reading one sector. Note 3. Floppy media and electronics are well known for being unreliable. Also no shit. So I'm guessing this is not described because they're like, hey, moron, obviously, you just keep reading until you are done reading. So the fun thing here is, you know how much you can store in one register, or the biggest number? It's 255, man, and I need to count to 512, which is twice that. So what I need to do, this is the part I was worried about, because this is just it adds overhead. You want this loop to be as tight as possible. But just even doing the check to see if we've overflowed one byte is going to suck. It is what it is. I think what we got to do is we will just let's set x to 0. I think I'm going to use that for my inner counter. Sorry, literal 0. And I'm going to use y for my, countdown counter. And I will set that to 1, I guess. And read sector byte loop. And yeah, here's the bit where, oh yes, so I'm going to, right, that's actually a really good way to do it, because I'm going to use, I think I really want to use an indirect 0-page access to write the data, because I just want X to index, and hopefully that in and of itself is not too slow an access mode. We're just gonna write it and see what happens. Okay, that's what we're gonna do. So let's go ahead and add some more 0-page thingies. I'm gonna call this FDC buffer address at 10 and 11. And that's where we will indirect through. And I think I'm good to just, I don't know, I'll use, we're using the 0 page, obviously. The first page on the 6502 is hardwired to be the stack area. So I guess I don't think anything's using page 3. I think that's memory we can use, hopefully. Didn't really check that first, but hopefully. So what we will do is before we do the sector transfer, we will set the address of that buffer. Yeah, this is going to be fun. Okay, this is a premature optimization for sure, but actually what I'm going to do is I'm going to set up 2 FDC buffer addresses. Let's do FDC low buffer and FDC high buffer. And that's going to be at 12. And what I'm going to do here is I'm just going to make 2 loops. Yeah, I'm just going to make 2 loops. When we finish the 1 loop that's writing to the low buffer, we'll switch to the other loop that will write the rest to the high buffer. And yeah, that should be good. Should be good, should be pretty fast. Yeah. And we'll just preset those 2 buffer addresses before we start the transfer. Sound good to you guys? Doesn't matter. That's what I'm doing. All right, so we need to set those. So load A 0 and then store it to FDC low buffer address, and then load A. What did I say? I'm going to put that in page 02. And store that to FDC. Oh Lord, yeah, no, this is right. It's little endian, right? I think so. Low buffer address +1. Set up the low buffer address. Copy all this shit. Yank it. Set up the high buffer address. Same deal, except this is going to be 3. I realize this is redundant. I could have just thrown 0 and X or something and used that, but too late. Actually, DC. Cool. It was just HI. I'm going to look at chat just in case my endianness is off here. Dave says, 1 little, 2 little, 3 little endians. I think that might be tasteless, but I'm okay with it. Oh, cool. Wareworm said, yep, and MFM is modified frequency modulation some time ago. Huh. I didn't think it was that simple. Dave said, decrease Y for something. And Santiago said, yay, premature optimization. Don't prematurely optimize. I don't do as I say, not as I do. Okay. Let's do it. So pretty much this should just be a JSR. Right. I don't need that anymore. I am going to start with X as 0. And I'm just going to detect if it overflowed, is what I shall do. So JSR read FDC data, and then that should put my data byte in the accumulator, and I should just be able to do store A to FDC low buffer address, comma X. Wait, is that the thing? Shoot, I always get these memory addressing modes screwed up. So this should be, oh, let's I'm sure Dave could tell me because Dave writes Apple shit all day long. He would know. No, I think this is the one. Because this indirects. And then... Frickin'. Which one do I want? Dave, which one do I want? Because that... Does that indirect into the 0 page first? It's the order of which of when indirection happens. No, I'm pretty sure this is the one I want. With the Y register. Sorry, just looking for my keyboard code because I know that something. I know in my keyboard code for looking up the junk in the lookup tables, I used the one that I'm looking for. Wait, what? Oh, because this isn't indirected. Oh, right, I didn't indirect this. I'm using the actual address offset by... I'm using literal X. Shit. I want to use one of these. And I can't remember which does which. Dave says, indirect always hurts my brains. I just can't remember the order and what these are implying. Okay, so the parentheses are indicating the dereferencing operation, right? The thing that actually is the indirection. So I think this would be saying it takes your 0 page address from 0 page, adds X to it, then indirects it, then does it. So if it was like, if your thing in 0 page was they will tell us. I don't have the brains for this right now. Bytes, words, addressing. I know. Okay. X indexed indirect, and then indirect Y indexed. So the operand is a 0 page address. The effective address... Oh, here we go. Yay. Hopefully, maybe. Uh-oh. No, their syntax. I can't read it. Oh no. LL plus X and LL plus X plus 1. So LL is the operand, right? LL plus X. I think it's the Y one, because I think we want to indirect it and then index it, not index it and then indirect it. I think. Because this would be used if you had like a table of indirect addresses that you wanted to reference by an index thing, and this is for if you have like a table that you want to index into, I think. So like this could be some arbitrary list of addresses that don't have to be contiguous, and you can reference them that way, kind of like a jump tables type situation, except not jumps, loading data. And this is for kind of actually accessing the data. Don't listen to me, I'm just gonna do the thing. FDC low, sure, that got us there. So let's switch this to Y, and let's switch this to indirects and then index. And then we will increase Y, And if y has rolled over, so if it's now 0 after that, actually, yeah, so if it's not 0, sorry, then we will jump back up to read sector byte loop low, which let me format that nicely. But if it has wrapped over, then we just enter the exact same loop, but it is using the high buffer address to finish the job. And do the same thing, and if until that wraps, then we jump back to here. You almost got me. Make sure that label is fixed up. All right. So there you go. There's the magic. I feel okay about these loops. I think. Fingers crossed. And now I have to read the result bytes, right? Not that it super matters, because this is the last thing I'm doing, so if things are out of sync, it's not like the world will explode. It's just gonna... the floppy controller is gonna be like, yo, bro, I got stuff to give you. And then just sit there and probably take a poop at some point, but I won't even notice. But I'll clean it up. I'll do it. I'll do it. You know what? You know what? I'm gonna do it. And I think the results are more or less the same as... Huh, interesting. Sector ID information after command execution. So I assume it probably reads the sector information off the disk as it's scanning it and returns that to you. Probs. Anyway, I don't care right now, so you know what I'm going to do is I'm going to... Okay, fine. I will stash these. I'll stash them. And I'll stash them. I'll stash them. Don't you worry about it. I'm going to do it. So we can look at them in the monitor. So STOs, ST1, ST2, CHRN. Let's just... I'm going to note that down and then flesh them out. So STO, ST1, just like I did before, ST2, and then CHRN. CHRN, and then I don't think this produces an interrupt or anything. Again, not that we would care. We'll care when we actually like try and read multiple sectors and make this more working code, but right now we just want to see if it works at all. So the fact that I'm even reading these bytes is frankly excessive. So I'm just going to do... let us do this. JSR, read FDC data. And store a, I will allocate these areas in a second, but store a STO result, and I guess just copy this several times and clean it up, is what I will do. STO, ST1, ST2, CHRN. ST1, ST2, CHR, N. Probably not even going to make this far. It's probably just going to hang. I am wasting my time. No, because we'll need this later. You will. C result, H result, R result, N result. Let's go allocate those. So that was STO result. We'll put that at 12 and 13, 14. ST1 result, put that at 15. ST2 result, put that at 16. ST3, no, that's not a thing. C result equals 17. Oh, I'm losing it. What were they? What were the other ones? CHRN. CHRN H result is at 18. R result we will stash at 19. N result we will stash at the glorious 1A. Grip it, rip it. I'm not gonna look twice. I'm gonna build it. We'll see what it does. Probably fuck up. And when it does, then we'll say goodnight and we will fix it tomorrow. So that leads us to a programming cycle. So it is at this time that I will attempt doing this and read chat at the same time. Dave says, I got to implementing indirect zero-page addressing and gave up on writing the new 6502 core. Really? That's pretty ironic. I'm sorry to hear that. You can do it. I mean, you've already implemented... Wait. Yeah, surely, like, you've written 6502 cores before. Oh, God. And then he wrote down the, like, the array indexed way of writing down how it is done, and yeah, that is correct. I can't even read that right now though, which is funny because that is very simple to read. Yeah, and Y will be the second one. Yes, no, that follows what I yeah. Oh, Dave says, yeah, doing it in C and assembly is way easier. Is it really? I don't know. I have written so little Verilog that I don't remember enough to even remember what syntax parts might be painful at this point. Because I feel like math expressions are pretty straightforward. I feel like index stuff would just be on that same... That might be the thing, is I don't know. Yeah, because it gets to be mathy, because it's not like you're just indexing an array or something. It's like you're actually calculating you're calculating the values of the addresses. Load the thing. We've been going for almost 2 hours. Good God. Good God. I'm going to explode. Okay. I think that was the right code. Hopefully. It's not going to work either way, so don't hold your breath. Oh, and Dave says, when doing it in hardware, you have to think about the sequencing. That is a decent point. Right. You can't just come up with a number and then jam it into a memory load command instruction, whatever you're using on your software platform of choice. You have to actually, in software, the sequencing is inherent to the design, right? Because the CPU is doing that part for you. But here you have to do all of that yourself. So it's several stages of, I would imagine, memory fetch and calculation and memory fetch and calculation. Yeah, that makes sense. Okay, right order. Floppy power on. NES power on. I'm going to tell you something. It did not work. But the interesting thing is, like, the head is down. I'm telling you. I don't know. Can you hear that subtle, like, kind of clicking noise? That is the sound of the head brushing against the disc. For sure. But it doesn't seem to be exiting. So we're just going to have to debug next time. Do I have to, like, tell it to unload the heads when it's done? Or some silly shit? I don't know, but we don't even have the monitor at this point because it's hung, so yeah. We have started trying to read a sector. I don't know how successful we have been, but I have put almost well, let's see. Yeah, 5 minutes to 2 hours at this point. So, blah, blah, blah. Cliffhanger, as Santiago says. And I'm going to decide whether I need to get some rest or put a couple of hours into making money. That's going to be a tough choice. Anyway. I hope I don't sound too defeated, because this is actually, this is pretty good. This is pretty good. We've made some good progress. I have a test floppy now, and we have the code that we now just need to debug. We've made good progress. Always progress, as we were saying earlier. It's just about progress. And I bet you money tomorrow we'll start figuring out some things about it and get somewhere and maybe find out that it has loaded everything into memory and we're super happy. Anyway, I'm just rambling on and on and on. Thank you, everyone, for checking in. It's good to see you. And until next time, you know it. You love it. See ya. I love you. Bye-bye.